Okay, yesterday we finished the video and stopped on these examples, and we're just going to take up the example so you have the right answers. If you haven't tried them yet, please stop the video and try and find out what the ion charge is for each of these atoms. All right. So again, when we do this, we need to look at a periodic table. So the first atom there is barium. So when we look at our periodic table, and we look for barium, it's right here, and that's in the second group of the periodic table. And it's 1, 2, 3, 4, 5. It's in the sixth row. So second group, sixth row. So let's take a look at that. If we're the second group over in the sixth row, now we could draw a Bohr diagram of this. And sorry, I didn't get the number. The Bohr diagram would have to have 56 electrons in it. So we could do that. The Bohr diagram would then have 56 electrons, and that's a lot to draw. But we can use another method for these called the Lewis diagram. And some of you would have done this in grade 9. A Lewis diagram only draws the last electrons. It doesn't worry about all the other electrons. So in this case for barium, I'll just do a little short form. We would do like 56 pluses in the center, and then you'd have to do 6 circles. So 1, 2, 3, 4, 5, 6, putting all those electrons in, and that would get things a little hard to do. So we can do a shortcut, and we can actually use Lewis diagrams to do that. So when we look at this picture again of the periodic table, and we find barium, the shortcut is this. The number up here helps us to know how many electrons would be in the last orbit of an atom. So because barium is in the second group, that means it's going to have 2 electrons in its last orbit. And when we draw a Lewis diagram, we just put down the symbol, and instead of drawing all the other circles, we just draw a picture of what's in the last orbit. And so we take those 2 electrons, one here and one here, and that's what we draw. And those are the 2 electrons on the outside that are very important. The rest of the electrons don't do anything during a chemical change. So again, if we go back to barium, we also notice that it's on the metal side of the table, which means then barium wants to empty this orbit. So metals, remember, empty their last orbit when they do chemical changes. So that means that barium's going to have to lose 2 electrons to empty its orbit. And if something loses 2 electrons, the word lose here, lose 2 electrons. If something loses 2 electrons, then we end up with an ion, because now it doesn't have the same number of protons and electrons. So we write down the barium. We don't put any dots around it. But if we had 2 electrons being lost, then that means that the charge here is now 2 positive. If you lose 2 negatives, you become 2 positive. Now we could do the math like we were doing before. Barium has 56 protons, plus, once you lose 2, it only has 54 electrons. And so that's 56 positives plus 54 negatives equals 2 positives. Okay? Just to finish that over here, right, we had 56 protons in barium, but because it was an atom, we also had 56 negative electrons. And so the charge was 0, making it an atom. Okay, so if you ask online, I can do another video on how to get Lewis diagrams, but they're going to make it a lot simpler, especially for the big atoms that we have to look at as we move forward, so that we don't have to draw out the whole Bohr diagram. Anyway, let me grab the next one here, and we'll do the next one just down below here. So I'll bring that down there. We'll look at sulfur. Now sulfur is not too bad. We can draw its Bohr diagram. So let's do this one using a Bohr diagram. So if we look up sulfur, we see it's here. It's in the third period, the third row. So it's going to have 3 rings, and it's going to have 16 protons and 16 electrons because its number is 16. But what I can also predict is that by looking at the number up here, it ends in a 6. So I know that sulfur is going to have 6 electrons in its outer orbit at the end. And so I could draw a Lewis diagram for this as well, but I'm going to draw the Bohr diagram first. So if we take a look at sulfur, it would be 16 positives. So 16 positives in the center to make a nucleus. And then we're going to have circles going around that. There's going to need to be 3 of them. So first orbit, second orbit, and a third orbit, like that. And then we have to add in the electrons. And the first orbit can have 2. The second orbit can have 8. 1, 2, 3, 4, 5, 6, 7, and 8. So that's a total of 10. And we need to get to 16. So that means we need 6 more, just like we figured out on the periodic table. So 1, 2, 3, 4, 5, 6. So that would be a picture of sulfur. Now, if we wanted to short form this and do it using a Lewis diagram, what we can do is simply write the letter for sulfur, and then just look at how many are in the outside circle, the last orbit, and there's 6. So we do the same thing here. We go 1, 2, 3, 4, 5, 6. And so both of those are good pictures of sulfur to be able to work from. Now, if we check the periodic table again, we can see that sulfur is in the non-metal section. Remember our line that comes down here. Everything on this side is a non-metal. And non-metals gain electrons, which kind of makes sense. If we look at sulfur, it either wants to empty or fill up this last orbit. So to empty it, it would have to remove 6. And that takes a lot of time and energy. To fill it, we only have to add 2 more. So we can add 2 electrons into this, and we add 2 electrons, then we can fill the outer orbit of sulfur. And that's just as good as emptying the outer orbit. But for a non-metal, they always gain or add electrons. So we could draw those in. Sometimes I use a different color to draw them in. I'll just go over here. I'm going to switch back to the Lewis diagram since that's easier for us to draw. So remember, it had its original 6 electrons. And then just to use a different color so it shows up, we added in 2 more electrons. And so now, because we've added 2 electrons, sulfur is in neutral. Over here it was an atom. It's now a sulfide ion. And because it picked up 2 extra electrons, it has a charge of 2 minus. Okay. All right, we'll do the last 2 here and see if you got those correct. So looking down here, we've got aluminum. So that's another metal if you check it. And phosphorus, which is a non-metal. So let's do those 2. Let's look at aluminum to see where it is. It's right here. It's just in the metal category. It's in group 13. So if we were going to draw a Lewis diagram, we could just use the last number to show the last number of electrons in the picture, and that would be 3. All right. Or you could draw 1, 2, 3 circles, put all the electrons into aluminum, and you would find out that it has 3 in the last one. So I'm going to short form this a little bit. Let's just go with aluminum. And because it's in group 13, the last part of that number is 3, so that tells me there's 3 electrons around aluminum. Now, aluminum is a metal, so it wants to lose. So we're going to lose all 3 of these electrons. 1, 2, and 3. They're all going to come off because it's easier for aluminum to lose 3 electrons Then to fill up this orbit, which would take 5 more electrons. So it's easier to lose 3 than to gain 5. And when you lose the electrons, the atom turns into an ion. And because we lost electrons, that ion becomes positive. And because we lost 3 of these electrons, it becomes 3 positive. Right? And so that is now the aluminum ion. Okay, and then finally one more non-metal. So if we take a look at our periodic table one last time, we can see that phosphorus is a non-metal. It's in the non-metal section. If you draw a Bohr diagram, it would have 3 circles with 15 electrons in it. Or if we draw a Lewis diagram, it's in group 15, and the last number of the group tells me how many electrons are in the last orbit. So there's 5. So we go back to phosphorus, and what we can draw is phosphorus, so that's a capital P, and there'd be 1, 2, 3, 4, 5, and 5, okay, it's a non-metal, so we know that it wants to gain. And then how many electrons do we have to add to fill it up? Well, to fill it up, it has to have 8, so we have to add 3 more electrons. 1, 2, 3, and that would fill up this outer orbit. Excuse me. So when we rewrite this, if we were to draw the picture, what we would have is phosphorus keeps its original 5 electrons because it was in group 15, but it's picked up 3 more electrons during a chemical change. And so because it gained electrons, it's going to be negative, and it gained 3 of them, so it's going to be 3 negative. And then we have not a phosphorus atom, but we have a phosphide ion. Okay, so I hope that helps to make sense of the things we were talking about yesterday. That just follows. If you didn't watch the first video, do that, and then this is just the practice afterwards. And I posted a worksheet, which I will add some answers to today, so you can get some practice trying to predict ions. Okay, that's it for now. Thanks.